Okay, for the chapter review, solving equations algebraically. So basically you have two types of equations. You have exponential equations, and then later you're going to see log equations. So in an exponential equation, you always want to get the base by itself. Okay, so this is 7 to the x. It's by itself. Once you get the base by itself, you're going to take the log. So you're going to go log base 7 of 124 equals your exponent. So log base 7 of 124 equals x. So remember, to put this in your calculator, we have to use change of base. So we have to take the log of 124, either close your parentheses or hit enter, divided by the log of 7. So change of base says you can take the log of this number divided by the log of your base. And I get 2.4, they tell me to round the nearest thousandth. So 2.477, because the next number is a 1. So 2.477 is x. So when you get to number 29, again, you have to get the base by itself first. So we first have to subtract the 9. So I get e to the x plus 3 has to equal 41. Get the base by itself. It's an exponential, we put it in log form. So log base e, which is natural log, of 41 equals my exponent x plus 3. So log base e, natural log of 41 equals my exponent. So again, on my calculator, I'm going to take the natural log of 41. So natural log of 41, I get 3.714. So if we want to write that down first, we can. 3.714 to the nearest thousandth equals x plus 3. And now I need to subtract 3 to undo to solve for x. So 0.714 I can do without my calculator. If I take 3.714, subtract 3, I get 0.714. You can always check your answers as well by plugging that back in. E to the 3.714 plus 9 should be something close to 50. Now we rounded this, so it's not going to be exact. Alright, so let's look at this one. Again, we have to get our base by itself before we can do anything. So I have to divide by 2. To undo multiplication, we divide. So 4 to the 3x equals 30. Got the base by itself. Now we need logs. So we're going to say log base 4 of the 30 equals my exponent. So we need to figure out what is log base 4 of 30. So to do that again on my calculator, if I want to find the log base 4 of 30, I'm going to take the log of 30, close my parentheses, divide it by the log of my base 4. So I get 2.453 equals 3x, and again, that's a 4, so I only go to 3. Divide by 3 to solve for x. So I'm just going to hit divided by 3. I get 0.818. When I round that, I have to round the 7 up to an 8, so 0.818. So you get the base by itself, then you use logarithms to solve it. Alright, so then on the back starts the log equations. So now with a log equation, we got the log by itself, we're going to put it into exponential. So 3 squared has to equal x minus 4. So 3 squared is 9. 9 equals x minus 4. I add 4 to both sides, and I get x is 13. That one I didn't even need my calculator for. This one is a base of e. So again, we're going to put it in exponential. E to the negative first has to equal 3x plus 4. We need to figure out what e to the negative first is. So I'm going to go e raised to the negative first power. I get 0.3679. If I want to round the nearest thousandth, I can say 0.368. 0.368 equals 3x plus 4. To solve for x, I need to subtract 4. So on my calculator, I will subtract 4 minus 4, negative 3.632, and then I'm going to divide by 3. Get divided by 3 on my calculator, and I get negative 1.211 negative 1.211. All right, and I'm going to hop to number 36 as well, because that's a log equation. Putting it at exponential when it's just log, remember it's a base of 10. So 10 raised to the negative second equals 4x. So when I take 10 and raise it to the negative second power, or maybe you know what that one is, it's 1/100th, so it's 0.01 equals 4x, and then I'm going to divide by 4. And so when I divide 0.01 divided by 4, I get 0.0025, which I guess if I'm rounding would be 0.003 if I round the nearest thousand. Okay, so that's the other log equation. The other log equation you see is 34, but this is where two logs are equal to each other. Remember, that's a little bit different. If the log of this equals the log base 3 of this, those two things have to be the same. If their logarithms are the same, they have to be the same. So there you don't really need to convert anything. You just say, okay, I know this has to equal this. Don't forget, when you have x's on both sides, you need to get rid of one of them. So I would probably, in this problem, add 4x. And then just solve that equation. Subtract 3 and divide by 11. And just leave it as 3/11ths if you want. If you want to get the decimal approximation, because it did say we could round, you'd have 0.273 if you want to put it as a decimal. Okay, and then the other two I just want to talk about are the exponential ones that you really can't use logarithms for, because these are both raised to a power. So with these kinds of problems, this one and one like 35, you have to get the same base. So when you see 16 and 4, what you need to realize is that you can write 16 as 4 squared. So just rewrite that problem. I didn't change anything except for the 16 I write as 4 squared. Well, 4 squared is 16, so it's nothing has changed. So now if I have a power to a power, I multiply those exponents. So 2x times 2 is 4x. So I just multiplied those two and got 4x. And now if 4 to the 4x equals 4 to the x minus 3, I know 4x has to equal x minus 3. So you have to get the bases the same, then you can set the exponents equal. And again, what would I do? I'd subtract x on each side, and I'd divide by 3. Okay, this would be the same kind of problem. I'd probably want to get a base of 4. So 16 I'd write as 4 squared, just like I did the last problem. Now here's the tricky part. 1/4 is 4 to what power? It's 4 to the negative first power, because it's 1 over 4. So I write 1/4 as 4 to the negative first power. Again, two places I have a power to a power. So here I have to take 2 times x minus 5. So I take 2 times x and 2 times negative 5. Here, negative 1 times 3x is negative 3x. So if 4 to this power equals 4 to that power, I know those exponents are equal. To solve, I would probably subtract 2x, and I divide by negative 5 and get x's too. So that's a special problem. There's one of those on the test where you have to get the same base. Then you can set the exponents equal. So again, real quick, what we did is when you have an exponential equation, make sure you get the base by itself and then convert it to log form to use your calculator to find the answer to solve for x. If you're given an equation that's a log equation, get the log by itself, which usually it already is, put it in exponential form, and solve for x. If you have two logarithms equal to each other, just set what you're taking the logs of equal to each other and solve for x. And then the other kind of problem is if you have two things that are raised to powers, but you can get them to have the same base, then you can set the exponents equal and solve for x. Okay, so those are all the types of equations that are on the test.